Okay, so you remember that we just talked about, we just talked about how an angle that is not part of a right triangle still has a sine ratio. It still has a trig function. So let's talk about what those would be. So I want you to think about this point right here, B, and this is supposed to be drawn kind of in at an angle so that we can clearly see that it is not a right angle, okay? So to get the trig ratio, remember that what we do is we come down here and we pretend that, we have a right triangle. And that is going to give me the length here and the length there. So really, what I could say my legs are going to be here are whatever x and y is. See, whatever x is, that's the length here, right? That is the length here. And whatever y is, whatever the y value is, that's going to be my length here, right? So what would be my length here? Well, you would know that if we take leg squared plus leg squared, that's equal to the hypotenuse squared, right? So in this case, if we square root the hypotenuse, then it is equal to the square root of leg squared plus leg squared. So here where the legs are x and y, we can just plug them in. X squared plus y squared is equal to hypotenuse. So we have over here the square root of x squared plus y squared. Okay? That is the length here for any value b. For any, whatever b value we want to pick that's a point on this line. So we can derive our sine by sine would then be equal to the y value of that point B over x squared plus y squared. Now obviously this works when A is at the origin, but if not, we would determine that this wouldn't be 0, but it would be x minus whatever value that is. So we'd have a different length, but we'd still use, we're still looking at the difference, between horizontal values and the difference between vertical values. How did we derive this as x? Well, it's x units over from 0, so x minus 0. So this is still, derived, the same way, and this is y units up from 0, so y units minus 0. So we're still, here we're taking x of b and subtracting x of a, right, to get this leg, and here we're getting y of b minus y of a, the y value of b minus the y value of a, because a is at the origin, right? Okay, so sine, again, sine can be defined as the y value over x squared plus y squared, at least in this scenario, right? So what would the cosine be? Okay, the cosine would then be adjacent, right? So that's pretty easy. That would be x over, this is the square root, sorry. Square root of x squared plus y squared, right? And tangent would simply be y over x, opposite over adjacent. Okay, so that's kind of important to think about. In other words, we can kind of start redefining, for any angle, really we can start to define what that angle, sine, cosine, and tangent ought to be. And we're really going to pay a close attention to sine now for a minute. Okay, so now we're gonna take a look at, deriving the area of a triangle. So let me just draw a triangle out here. So this is a triangle. So we just kind of remember that the formula for a triangle is area equals 1/2 times the base times the height. Okay, so let me place this point C over here. And we'll say that this is point A and this is point B. And now we're going to say the measure of this side, and this is kind of funny how it always happens in the textbooks, but they like to say little a is the measure of the side opposite capital A, big A, see? So then this side over here measure would be little c, and this side over here would be little b. And it just helps us kind of keep track When I talk about little a, I'm talking about the measure of the side opposite big A right here. So now, if I thought about what would my formula be here, well, it would be 1/2 times my base, and looking at it like this, I would probably call A my base times my height. But that's the measure I don't have. I don't have a height here, and I don't have a height there. So now's when trigonometry comes in very, very, very handy. Let's take a look. If I actually drew my height, it would be a vertical line, or a line that drops down such that it meets right here. This is what we call an altitude, right? So it is a line that starts at the vertex and drops across the opposite side such that it meets at a right angle. Well, guess what? We now have a right angle triangle that we can talk about, so we can figure out some things here. Now we know that this is h, or let's call this h, the height, right? We were talking about this is our height, our unknown height. So let's write a function considering angle C. Let's write a trig function that involves this and a measure that we know. Well, we don't know this measure, right? But we do know this measure. And we know this whole measure is A, right? But we don't know just to that point. We don't know how much that of it is. It's something less than A. But over here we have the full measure B. So we can do from this angle, we think about the trig function that's opposite over hypotenuse, and that's sine. So sine of angle C would be equal to opposite over hypotenuse, which in this case, the opposite is H, and the hypotenuse is equal to B. So now, can we figure out, write it again, here we go, sine of C is equal to H over B. That makes sense? This over that. We know that's the answer there. So can we find out what H is? Sure, we can rewrite it using algebra. We would times this side by B times this side by B, and B is going to cancel. So B times sine of angle C is equal to my height. Wow, that's pretty cool. That's pretty cool. I can find the height of my angle using a trig ratio. Even though I don't know, all I have to know is this angle and that one side. If I knew this angle and this one side, I can find the height of a triangle. What that means is that if I know this side, because that's my base, and this side, so I can find my height using a trig ratio, I can find the area. What are we going to do? Well, let's start with the area of a triangle. Again, area of a triangle is equal to 1/2 times the base times the height. And let's substitute what we know our base is in here. Our base is little a, so the area of that triangle is going to be equal to 1/2 times little a, right, times the height. Well, what we know is this is the height. So 1/2 times a times, and then we just substitute in here, b times sine of c. Dun, 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 dun. If I gave you a word problem and I said, okay, solve this triangle's area for me, you could do that now, provided that you have what information? This is a capital C. This means the angle measure here, right? The angle measure. You need to know your angle measure there. You'd need to know your length here of one side of this triangle, and you need to know the length of the other side. And actually, we could turn this triangle any direction. So if I had a triangle that looked like this, as long as I know some angle here and two of the sides, even if I don't know the other side, so two sides, right, and this angle in here, I would find the area of that triangle by saying, well, give me 1/2 times A times b, that's little a, little b, times the sine of that angle. Saying, I'll call it angle theta. For any triangle in any position whatsoever. Okay, we're just going to have to try this out. Let me get a couple of things up in GeoGebra and let's take a look. Okay, so what we're going to say is that we can use our new formula for the area of a triangle for any triangle that you might come up with. And how would we do it? Well, we have to know, as you remember, little a and little b and the sine of theta, or capital C, right? Capital C. So we're going to measure an angle on each of these. So let's try measuring this angle. And why don't we try measuring this guy right here? Oh, let's do that again. Oh, let's try one more time. Let's try this. Oh, I forgot to put the tool back on. Ooh, Mr. T must be getting tired already. It's a little early to be this tired. But, all right, here we go. And we'll find it out for B over here. Okay. Now, we have to know, we don't know the height of any of these triangles, right, or the altitude. But we have to know at least two of the sides, right, two of the adjacent sides. So now we're going to go ahead and measure those sides. So let's get a length over here, distance or length, and we'll touch that side, and we'll touch this side. And we have to find, these are the adjacent sides, right? Okay, and we're going to find the adjacent sides here. All right, let me get my thing, and we'll kind of work through this here. Okay. So now, these are three random ones, and I'm going to work through them as quickly as I can. Pause and get set up for it. Okay, so now I've got to remember my formula. I'm going to show you a little trick that's pretty neat to do here. And I can define it. So I'll just say define, and I'll say, you know, I'll call that area triangle, TRI. I'll just go ATRI equals. So it's going to be equal to my formula, which is 1/2, right, times little a times little b times, I'm going to call it t, little t, which will stand, oh no, sorry, times the sine of t. So that's the sine of theta, right? T will stand for theta. So I can hit that in. And I can know that all I have to do is plug in what is A, B, and T. So I'm going to put define, right, that A, oops, let's see, I'm going to define A is equal to, so I'll make that equal right here to 6.65, and enter, and define that B is equal to 2.45, enter, and T, oops, define that T is equal to 36.97, enter, and then I can do my area of a triangle and just hit enter. So it says 4.899, and I'm about out of time to do those other ones, so we're just going to have to check the area of this triangle is 4.9, which is 4.899 rounded, right? So you can see that it works. Let's see if I have time enough to change this. Area is, the next side is 2.8. I'm going to use 2.8 and enter. And B, I will make that be, instead of 2.45, it's going to be 5.16. I don't even have time to point. You're going to have to follow along. And T is going to be equal to 146.66. Oh boy. Let's see, 146.66. I'm running out of time. And enter. And then I can find my area of that triangle, 3.97. And let's find the area. 3.97. It works. Congratulations.